Hello, we are Jinwon Byun and Chanun Park, students of the Department of Mechanical Engineering at Gyeonggi University in South Korea. We are interested in topics such as DNN, digital twin, nonlinear models reduction, and FMBD. We are very pleased to participate in this RTL Global competition. We would love to build valuable experiences with digital twin and ROM AI through this competition. From this competition, we were hoping to draw a tag pattern using VBT model provided in the RTL Global competition website. For the sake of information, tag pattern represents circle shape that is filled with red and blue colors in the South Korea flag. To do that, we divided our plans into 3 different tasks. Task A: to acquire data gathered from a real-world system. We downloaded the data from the RTL Global competition website to use it in the analysis of ROM AI. The data represent the values of x, y, x dot, y dot, x degree, and y degree, depending on the time in seconds. Task B: to create a reduced order model using AI. We use the RTL Activate program to train data we obtained earlier, and select data file to be trained and then folder to save the trained data. We set x degree and y degree as input, x millimeter, y millimeter, x dot, and y dot as output and state. Also, to represent the physical constraint, we set the derivative of x millimeter and y millimeter to be x dot and y dot. We use the hyperbolic tangent as an activate function. To minimize the standard deviation error during the data learning process, we set the value of hidden layer as 4 and neuron number as 24 to appropriate R-scale value. The AppBack value was set to 500, and the rest of settings are as follows. We then compared the 2 R-square values of original data and trained data, and find out that the R-square value were 0.91 in x dot and 1.16 in y dot, representing the outputs. Task C: to validate ROM AI to digital twin system. The first thing to do for testing is to import the learned data from ROM AI BBT. Select a folder as follows. We made changes to model code to set the tag pathway. We set the total time to 30 seconds to draw our own tag pattern simultaneously in 3 different sections. Prior to learning code, we made sure the parameter values are correct. We then set the time to allow the program to run only 1 cycle. Upon finishing of the setting, click the Run button. If it follows the tag pattern line, it indicates the program learned its accuracy. You can see that the table view is being read simultaneously with the right pathway. We then save the file as our new tag pattern in the CSV format. To ensure if the file isn't corrupt, we checked it by reopening the file back on. One downside we faced during the preparation to this competition was to find the exact rendering method. So we used the downloaded file from website of RTL Global competition in year 2021. We went through the process of replacing the file we received as RTL logo from the file into a new CSV file that we obtained. In setup, we set the time to be 30 seconds, which was the same time used in the previous setting. Rendering was carried out with a result obtained in the process. We ran the H3D file obtained from the previous slide. We opened the H3D file and set the unit to millimeter. In addition, we put the shape of the plate to check if the ball followed the tag pattern well. Also, the shape of the university was added to the ball to form the following shape. Finally, we were able to confirm that the tag shape was well followed. To sum up, we were able to obtain new input and output that followed the tag pattern well by training ROM AI using the given data. One obstacle that we faced was lack of ability of our team to design our own rendering process. We hope to resolve this issue for the next competition. Thank you for your interest in our Gyeonggi University team's presentation.